What is up, guys? Welcome to another episode of Math Made Easy. And today we're just going to be mostly graphing. Now, a lot of us have been having problems with, observing lines and kind of stuff like that, right? And I feel like sometimes a good graphing session is all you need for that to happen. Sorry about that, guys. Just had to take a call from my friend. By the way, he has a channel, right? It's called Bob Frida, all caps. Sub to him. He does gaming. So let's get into it. So this is, we're graphing, and you see I've already graphed a line here. Y equals x, right? We're just going to use this line as a reference, because this is kind of like the diagonal line, if you were to say. So we're just going to notice patterns when we're graphing in slope-intercept form and standard form. So here we go. Let's try things like y equals 2x. So 2x means it's steeper. Okay, let's try y equals 1/2 x. Nope, not 1 over 2x. Sorry, guys. You see, this one is a little bit, it's not as steep, right? And in fact, this green line and the blue line, they're just reflections of each other off the red line. So notice, these are just like this. They're, if you were to take this one and mirror it across the red line, it would be this. Okay, let's try some other things. Let's graph y equals 2x, and then let's graph y equals 3x. So you can see the black line is steeper than the purple line, right? And you can also see that as this number right here gets larger and larger and larger, this line gets steeper and steeper and steeper. So if it's y equals 1000x, it's practically vertical. We also see if it's 1/3, not negative 1/3, sorry guys, 1/3 of x. These are also reflections of each other. Similarly, that is also what happens if we put like 5x, and that will happen for everything. The reciprocal of the coefficient of x, so like if it's the reciprocal of 5 is 1/5, right? They will always be reflections if there is no like plus b term over this line. What if we say y equals 5x plus 2? Actually, let's first just note that if we put minus 5x and minus this, these are both reflections of each other still, because of course they're reciprocals. We just notice they're going downhill. And if we just say y equals 5, say, that's a straight line. I mean, and if we say x equals 5, that's a vertical line, not a function. Okay, so what if we were to have, say, something like y equals 2x plus 10. And then we'll graph our line y equals 1/2 x. You notice these are no longer reflections of each other, right? Because, this point mirrored across this line, this point is not on the black line. But if I put this on minus 10, they don't quite become reciprocals yet. They're actually but we see that when we put this at 5, then the reflection comes. Okay? Let's try it with a different line. 3x plus 10 maybe, and the third x plus 5. These are not reflections. They're reflections about the line y equals x. If the point of intersection is on y equals x, which you can see it's not if you look really closely down here, it's not. And if their slopes are reciprocals, so the slopes are reciprocals, but the y-intercept is not the y-intercept, sorry guys, the intercept with y equals x is not right. So let's try. You notice this now, which is about 10 over 3, we see here, these lines do, in fact, meet up. And that is, in fact, because of these numbers, right? What you will notice is if you set the y-intercept of this first line to like 10 maybe, you would divide 10 by its slope, so 10 over 3, and make it negative to find the y-intercept of this second line. Okay? So we're noticing kind of reflections and patterns in that. As a final note, just gonna see as we increase the y-intercept, the line kind of moves higher up, but its slope does not change. Okay. So now we're going to talk about standard form a little bit, right guys? So standard form is very evil, I agree. But it looks something like this. 3x minus 2y equals 5. So in this case, it's easy to find the x and y intercepts of this kind of thing on slope-intercept form. I mean, not slope-intercept, on standard form. Set 3x equal to 5, it's 5/3 is our x-intercept. Set minus 2y equal to 5, minus 2.5 on our y-intercept. And you'll notice that whenever there is a minus sign right here, like something x minus something y, this will be a positive sloping line. So it's kind of counterintuitive. Whenever there's a minus sign, it's a positive line, positive sloping line, and whenever there's a plus sign, it's a negative sloping line. We notice that as we make the x bigger, like 9x is much bigger than, say, 3x. The slope increases. So as the x increases, the slope increases, and as the y increases, the slope decreases. Or you could say the slope increases, but the slope relative to vertical will decrease. So then the last thing we're going to observe is about this number. As this number increases, the line gets further away from the origin. If it's only 1, it's really close. If it's big like 10 or even 100, it's way out there. It's further and further from the origin, right? And hope we all understand that principle. And now we have to look at it relative to y equals x. In this form, it's going to be x minus y equals 0. Oops, sorry. So if we have 3x minus 2y equals 1, let's just say, 0, let's just start with 0. And then we have 2x minus 3y equals 0. These will always be reflections over this line. If this and this are flipped, as so that's the reflection, the sign should not change. But it's also true when there is a plus sign in here. So what if we set this equal to, say, 5? Let's try to set this equal to 5 too. These definitely aren't reflections, guys. Let's try to set it to -5. Oh, can you believe it? They, in fact, do reflect. So, no matter what the slope is, I could say 2x minus 10y, or 3x minus 10. I mean, actually, no. 10x, I meant. And these should actually still be flips. So in this form, as long as these are like -5 and regular 5, positive 5, as long as they're, you know, the kind of the opposite on the number line, the negative form of it, we're going to be good. So, quick recap, slope-intercept form. We have it reflects across the line y equals x if the slopes are reciprocals, and the y-intercept of the second one is the y-intercept of the first one times the negative slope, or times the slope of the second one, plus, and then just that number negative. Standard form, if these numbers flip, like, you know, if you take 10x minus 2y and make it 2x minus 10y, those will become reflections. And to use the y-intercepts, you will do this 5, positive 5, just make it into a -5 for the other thing here. So I really hope that helped you guys, and I hope you had a fun time with it, because a lot of people do have trouble kind of thinking of all the different forms of lines, and I'll do something on point slope form later, but gotta go for now. So this is standard form and slope-intercept form. I hope you enjoyed. Leave a like if you did. Subscribe, comment your ideas, and have a nice day.